In the previous video, we saw how we could use a method to determine the sum of a particular geometric series. That one was where the first term is 1 and the common ratio was 2. Let's try and generalize that method now. So the sum of the first n terms is u1 plus u2, but u2 is u1 times r, and then u3, but that's u1 times r squared, and then u4, but that's u1 r cubed, all the way up to the nth term, which is u1 r to the n minus 1. And then what we're going to do is we're going to multiply that whole series by r. So we get u1 times r, u1 times r squared, u1 times r cubed, u1 times r to the 4, and u1 times r to the power of n. If we then shift the second of those ones along, just so it's the same sum, it's just written in a different location, it makes it easier to see what's going on. So we have our first one, and then underneath that we have our Sn, and this time I'm going to shift all of them along by 1. So it starts with u1r, u1r squared, u1r cubed. We're going to have a u1r to the n minus 1, which is the term before this one, and then the last term is u1r to the n. And what we're going to do is we're going to subtract the first one from the second one. But what that means is when we do the subtraction, all of these terms appear in both equations. So when we do the subtraction, all of those terms are going to cancel out. So we're going to do Rsn minus Sn, and then we're going to do all of this one minus this one. So the only thing that's left on the right hand side of the first equation, or the second equation, sorry, is u1 r to the n, and then from that everything else cancels out. We're just subtracting u1. Factorizing both of these, we get Sn r minus 1 on the left hand side, and on the right hand side we get u1 r to the n minus 1, which means that Sn is equal to u1 r to the n minus 1 divided by r minus 1. Now sometimes we see that written slightly differently as 1 minus r to the n on the numerator and 1 minus r in the denominator. And these two are equivalent. You can use either of them. You're given them both in the formula booklet. The convention is to use this one when the magnitude of r is bigger than 1, and this one when the magnitude of r is less than 1. But it doesn't actually matter. It will just, if you do it that way, you end up with positive numbers, so you don't end up with having to deal with negatives, but the negatives will cancel out anyway. It's not a particularly big deal to use the other one. So both of these are valid, and you can use either as you wish for any particular question. And that is the formula for the sum of a geometric series.